its config, and when we're peeking and poking around operational mode, I mean, we've got management interfaces such as FXP0, we're all familiar with. Maybe some EX platforms you might be playing on have an ME0 or VME, Management Ethernet and Virtual Management Ethernet. But same thing, still out-of-band interface. Internal interfaces like FXP1, linking the routing engine down to the PFE, the line cards within the chassis. So never configured, already managed by you, the end user. But it's there for internal connectivity. In fact, FXP1, FXP2 are there for the redundant purpose of RE to PFE connectivity. Some other platforms, we might say BME as well. Really, the interfaces we're focused on most of the time, they begin with some media designation, some network that we're connected to on a physical wire. So for Ethernet, it could be FE for fast Ethernet, GE, gigabit Ethernet, and you can see the 4 options we have there go up in order from 100 gig, 1 gig, 10, and ending in ET for 100 gig Ethernet interfaces. Maybe we've got some old school packet over SONET or ATM interfaces to play with, or serial, channelized serial. The list is a lot longer than we're showing you here, but you get the idea. Many interfaces begin with a 2-character media code simply to indicate the type of layer 2 interface we're dealing with. We've also got service interfaces. Service interfaces are usually fulfilling some kind of software role in the background. You, the user, are not too worried about what they are. So PIM-E, PIM-D, for example, the PIM encapsulation and PIM decapsulation interface are only really relevant to you if you've actually configured multicast, and more importantly, there is some kind of exchange of multicast registration messages with the rendezvous point. You're not going to configure them, but maybe it's interesting at some point when you understand more about multicast in Junos to have a look at the statistics there for registration messages going back and forward. Similarly, we could have GRE template interfaces. We could have SP service process interfaces, so which would relate to a system that has a service card installed in it, a card that doesn't have any physical ports, but is being used for something like NAT or IPsec, for example. So those SP interfaces might be there in the output, relating back to one of those features if we've configured it. Loopbacks are a little bit different to what we're maybe used to with iOS. In iOS we had loopback 1, loopback 2. In Junos there is definitely only a single loopback physical interface. There's a strange thing to say. By that I mean IFD. LO0 represents the major loopback interface, and underneath that we can configure multiple sub-interfaces. So there could be LO0, .0, .2, .3, and maybe that's because LO0 Unit 0 is tied to the default inet.0 routing table, and we've created other sub-interfaces under LO0 and tied them to their own VRFs, their own VRF lights, if you like, in Cisco terminology. Any one of those loopback units could quite happily contain multiple IP addresses. So it's not the case that we need one loopback per loopback IP address. We just need one loopback and sub-interface per routing table, per routing instance, if you like, on the box. So interface naming, we've seen a couple of times different examples, but not discussed in detail. A little bit of history here. Originally, a long time back, with the very first routers Juniper released, every line card was referred to as an FPC, a flexible PIC concentrator. That line card had multiple modular PICs, physical interface cards, PIC cards installed in it. And those PICs had some number of ports. It could be 1 port, on higher speed interfaces. Could be 4 ports for maybe fast Ethernet or something. But you get the idea. A particular line card, a particular FPC sat in some slot within the system chassis, and then we could even choose to insert within that line card slot different PICs numbered 0 through, well, in this case 0 through 3. So topmost PIC 0, 1, 2, 3 down to that bottom PIC there. So unfortunately, things moved on. Juniper released more routers, and these days we might equally talk about FPCs and MPCs and DPCs. I mean, they're all line cards, and they all sit in some slot number. But from the documentation point of view, and very often in the CLI, we see reference to FPC regardless of which type of line card is installed in the system. So our interface names are made up from a combination of the media code, GE, SO, AT, whatever it might be, the line card physical position, the PIC slot position, and some port within that PIC slot. Now, again, a little bit of a historical note, it's very likely at some point you'll come across line cards that don't actually have modular PICs. In fact, maybe you're dealing with MPCs, modular port concentrators, if you like, if you want for the acronym. And those MPCs don't contain PICs, but contain MICs. Okay, the naming of the interfaces hasn't changed. Junos, or rather Juniper, decided to be consistent. We're going to keep the same format of interface naming, even though different generations of router have had different line card and interface slot names and so on. So first number, if we look at our example here on the slide, GE02023, first number on the left is always indicative of the physical line card slot. The middle number may actually relate to some insertable PIC or MIC or some device we can pull in and out of the line card. Though generally, even on fixed line cards where nothing is removable, all of the ports are embedded direct into the line card, we still group sets of ports by middle PIC numbers. So, the first 10 ports on a DPC, might be 0 through 9 in PIC position 0. And then the next 10 are ports 0 through 9 for PIC position 1, so on and so forth. And then finally, that third number, in this case, G023, 3 here being the port number we're actually inserted into. And of course, we will come across sometimes interface names that don't relate really to any physical interface. Don't relate to some physical position in the chassis. We might be talking about aggregate Ethernet or VLAN interfaces that are part of a bridge domain, or loopback interfaces. Right, so some key points to remember that are a little bit different from what we know in iOS. In Junos, there is always a sub-interface. Okay, that doesn't really make sense if you think about something like, I don't know, a serial link with encapsulation PPP, or Ethernet interface without VLANs. If there's no VLANs, how does it make sense that there should be a sub-interface, a unit number? Well, Junos in that case, if some encapsulation that doesn't require multiple sub-interfaces, Junos still wants you to use unit 0. Now, if we turn on the correct encapsulation, nothing stops us then creating unit 100, 200, so on and so forth. And for sanity's sake, we hope that you choose to align sub-interface unit number 100 with VLAN ID 100 or DLCI 100 or whatever, but they don't actually need to match. If you're feeling sadistic towards your colleagues, nothing stops you creating a unit 100 and setting the VLAN ID to 200. Okay, much fun for you and the ops guys, down the road when you forget about that, but it's perfectly possible to make that configuration. And then, of course, under each of these units, we're going to choose to configure IP addresses. Multiple IP addresses or a single IP address, no problem. Again, something to watch out for Cisco folks switching to Junos. In iOS, if you typo the IP underneath some interface, you simply reissue the IP address command, and you overwrite whichever previous primary address you've configured. Because in iOS, you're going to add secondary addresses only when you remember to include the secondary switch at the end of the command. Well, in Junos, it's the other way around. If you configure one IP address, make a typo in the octet, arrow up, call it back in the history and run it again, well, what you've actually just done is add a second address to the interface. So Junos wants us to list multiple addresses and flag one of them as primary, as opposed to iOS, where we configure multiple addresses and flag many secondaries and leave one primary.